My neighbor is an elderly lady, and she is very suspicious of TxDOT. And there's one thing that she's more suspicious of, and that's drones. So you can imagine her reaction when I told her that I was going to be giving a presentation on drones at a TxDOT conference. Offered to show her the presentation, she accepted, so I went over to her house with my laptop, started giving her the presentation, and about halfway through she stood up and she said, "Stop, that's enough." And she showed me to the door. And she's 80 years old, she doesn't have a lot of internal filters, so as I stepped out on the porch, with the door closing behind me, I heard her say, "Damn, that was boring." So I just wanted to let you know that this presentation is not approved by my neighbor, Sarah. So let's start with a little terminology. Drone is a generic term. It's popular. I have no problem with it. I tend to use the word or the acronym UAS when I'm talking about the entire system, the aircraft in the air and the control systems. I'll use UAV when I'm talking about just the critter that's up in the air. And then RPAS, you hear that sometimes, that's a military term, and I typically don't use that. In regards to drone activity at TxDOT, like a lot of technologies that we follow, we do the usual monitoring. We read the technical papers and the peer-reviewed articles that come out. We go to conferences, we talk to other DOTs, other state agencies, our commercial partners, and we participate in rulemaking when we get the chance. Today, I'm going to talk specifically about a TxDOT research project that is underway investigating the potential uses of UAS for transportation. Unlike a lot of technologies that come along, UAS has considerable safety, regulatory, and legal components that make it a little bit challenging to put this technology to work. And safety, the safe operation of a UAS, that's the major concern at TxDOT. We hear about near misses with UAS, between UAS and manned aircraft, and our aviation division will not tolerate this type of incident. They won't tolerate the possibility of damage to property, injury to a person, or fatality. And so safety is the main issue for TxDOT. In addition to safety, the operation of drones for commercial operators and for state agencies is regulated. The airspace, National Airspace, is regulated by the FAA. The state has the ability to regulate airspace. The state of Texas has 3 laws on the books, one of which says that you can't operate a drone around the Capitol. But what a lot of people don't realize is local municipalities, cities and towns may also have the ability to regulate the use of UAS. If you think about noise abatement laws, which have been upheld in court, noise abatement laws, they limit the hours of operation of an airport, and that is in effect a control of airspace. And so in addition to the federal and state laws, we may also have to deal with local regulations. The regulatory environment is evolving, it's changing, and so we have to be prepared for that too. Aside from the regulatory concerns, UAS is a relatively new technology, and the case law surrounding the operation of UAS has not been developed yet. And by case law, that's when the lawyers get involved. So you have a new technology, you have critters flying around in regulated airspace, you have evolving regulations, and you have lawyers, and that's not a real good combination. So we have to be a little bit careful when we're looking at implementing a technology like UAS. Because of the safety, legal, and the regulatory environment, TxDOT's taking a cautious and methodical approach in determining how this technology may potentially be used. On the positive side, there is considerable evidence that UAS can provide benefit to the agency. It can potentially improve safety for our field crews. It may allow more efficient safety monitoring of construction sites. It may improve data acquisition efficiencies, and it may even improve our accuracy, amongst other things. And so, like any potentially beneficial technology, the agency is interested in seeing what this technology can do for us. So today, I'm going to talk about a project that's underway at TxDOT. It's number 06944. You can see the title of it there on the screen. And what I'll start with is 40,000-foot overview, and then after that, I'll drill down a little bit to talk about how we do research projects at TxDOT, and after that, we'll dive right into the task and the actual body of the project. So in January of this year, there was a meeting held at the Greer Building, and present were staff from administration, from divisions, from the Office of Strategic Planning, the Research and Technology Implementation Division, along with some technical staff and some university researchers. The consensus from this meeting was that UAS does have the potential to provide benefit to the agency. And as a result, a research project was initiated to be led by the TxDOT Aviation Division Flight Services Section. Those are the guys who fly our airplanes. The TxDOT Research and Technology Implementation Office would provide project administration and project management for this project. And let me stop here for just a second. I want to point out that at no point has anybody said or suggested or intimated or even insinuated that TxDOT is going to go out and buy drones. We're not buying drones. Okay, right now, what we're trying to figure out is, can we operate safely in the national airspace, and does a drone provide us some benefit over technologies that we already use? We have a lot of questions about the safety end of this. I have questions about the technical ends of it, and then there's a lot of questions that have to do with the procedures. So what this project does focus on is how the agency may go about using this technology, and why would we choose this technology over something that we already do? Okay, so there has to be some sort of benefit, cost benefit or time benefit. The how question is the operational part. So how do you operate a UAS safely in the national airspace? On the slide I also have there, how do you stay out of trouble? And by that I don't necessarily mean how you stay out of regulatory trouble. I mean, how do you do things like avoid endangering people or property? How do you avoid distracting drivers? How do you avoid losing an aircraft? And just in general, how do you avoid doing something boneheaded that'll get you on the 6 o'clock news? And so the results of the operational part of this project will be a TxDOT standard operating procedure. It may be one document, it may be several. Anyone using a UAS to do work for TxDOT will be required to follow, well, to know and to follow the guidelines within the SOP. The why part is the applications part. How does the technology benefit from using this technology, or how does the agency benefit from using this technology? And from my perspective, the why part is actually the easy part to answer. Unless there's some completely novel use of a UAS that we've completely overlooked, any potential application is already being done by some other technology, right? So we have vertical photogrammetry, close range photogrammetry, multispectral and thermal scanners, LiDAR, visual inspection. All these things are already in our toolbox. So all we have to do is figure out if we can do it better using a drone. So that's a 40,000 foot overview. Now I want to take just a couple minutes to talk about how these projects evolve at TxDOT. This part's kind of interesting to me. This is the first time I've ever worked with the Research and Technology Implementation Office. And that division has the authority to contract research projects with state-funded universities. They provide, like I said, administrative support and project management. The team, shortly after the UAS project was initiated, RTI assembled a project team. And this team looked at all the potential uses of UAS within the agency. They identified 18 general application areas. That list of 18 was eventually narrowed down just to 2. And the reason for that, there are a couple of reasons for it. One was to kind of control the project, because otherwise it could be a really huge project. It allows us to control the budget and also do a little bit more focused approach. But we also realized that a lot of the applications of UAS between those 18 different general areas kind of overlap, right? There's really, honestly, there's only that much stuff you can really do with a drone. And so by using just a narrow focus, we're able to answer all the questions that we need to answer with a controlled project and a controlled budget. So the 2 application areas that we chose for this project are pavements and rails. And when you think about it, you think rail, that doesn't make a lot of sense. We got a lot of road, we have a lot of pavement, but we don't have a whole lot of rail. So why on earth would we choose rail? And the answer is because rail provides us some unique logistical advantages over working in other areas. The state of Texas owns the South Orient Railroad that was mentioned a little earlier today. TxDOT manages that right away on the railroad. It's located in a remote area. It runs from Presidio to San Angelo, and it also is in areas that have very low population. So if we conduct rail operations, a lot of the complexities of operating near a roadway are gone. We don't have to worry about traffic. We don't have to worry about traffic control. We don't have to worry about distracting drivers or onlookers. With rail, we can focus our efforts because we're working in a very controlled environment. And if you think about it, a lot of the types of data that we're collecting, a lot of the type of tasks that we want to accomplish, you know, rail provides us with infrastructure like bridges. It has utilities, it has right-of-way. It basically has a lot of the same characteristics that a roadway has. And so it works out real well for us because we gain the advantage of working in a controlled environment, and then we don't have to worry so much about the safety issues. And by the way, we do know where the trains are, so we don't have to worry about the trains. Once the two application areas were selected, the project team developed a very complex scope of work. And this is where working with RTI has been very different than what I'm used to. The project team, as I said, developed a very highly detailed scope of work. It included processes, procedures, accuracy specifications, data validation procedures, and reporting of deliverable requirements. It was 20 pages long, it was single-spaced, and the text was just tiny. So there was a lot packed into that 20 pages. RTI took that 20-page detailed project scope, and they boiled it down to a 2-page problem statement. And basically what it said was, we're interested in this technology, we want to know how to fly safely within all the regulations, and we want to know how we could apply it to pavements and rails. And that was it. And that 2-page problem statement is sent out to universities, to the researchers, as a RFP, a request for proposals. RTI does this because they know how we want to do the work. What they want is for the university to tell us how they would do the work, because the universities are on the cutting edge of innovation and technology. And the interesting part to me about this whole process was that when those responses came back, they were spot on. The universities described a project that was exactly what we wanted. It covered a comprehensive standard operating procedure, analysis of airframes and control systems, analysis of the sensors that are carried by the UAS, detailed description of the field data collection and analysis tasks, and they included work breakdown structures, budgets, timelines, milestones, and deliverables. And so the proposals that came back were evaluated and the project was awarded. Now I'm going to have to tiptoe a little bit here because the contract for research actually hasn't been signed yet. We're about a month behind, and it should be signed, I believe, probably next week or perhaps a week after that. So I can't say what university or universities are participating. I can tell you that the project team is very well qualified, and they're excited to get working on this project. And so that's how the project was developed, and what I'd like to do now is just jump right into this project and go over the different tasks and how it's going to be implemented. So by now it should be fairly clear that we're talking about two different main tasks. We're talking about operational, which is how do we fly in the national airspace safely and within all the regulations, and then we're talking about the application tasks. The application part is how do we use this technology. Budget-wise, the two are split about 50-50. Between these two. Schedule-wise, the application part takes much longer because we have field work involved. There's a lot of logistics there. The operational part also, it benefits from our experience and expertise within our aviation division. Our aviation division already has a very detailed standard operating procedure for their manned aircraft. And so the UAS project will start with that as a guide, and we'll develop a UAS standard operating procedure from there. For the applications part, the project contains data collection that's both qualitative and quantitative. So qualitative would be things like visual inspections, any sort of thing that depends on the judgment of an inspector or a subject matter expert. The quantitative ones are the ones that involve some sort of metric or measurement. Data validation is a very important part of this project. It is particularly for me because I read a lot of peer review papers and research papers. And the one thing that I find consistently lacking is very good data validation that actually kind of makes sense to me. So for this project, the qualitative, which is the inspection type work, the data validation comes from an actual on-site expert. When we're doing bridge inspection, we're going to use our bridge inspectors. Rail inspection, we'll use our rail inspectors. And it will be their judgment to tell us the efficacy of using UAS for those inspection tasks. For the quantitative tasks that involve measurements, the UAS data will be validated using surveying equipment that operates at a higher level of accuracy. So we're talking about survey grade total stations and digital levels. For the most part, we're not going to use GPS surveying because the accuracy is just not high enough. With this close range photogrammetry, we're talking about very high accuracies. We have a built-in data validation for the standard operating procedures. The standard operating procedures that are developed under the operational part will be used in the application part. Of course, we'll have oversight to make sure that we didn't miss something in those SOPs, but that'll provide a good QA/QC on the operational SOP. And so there's 7 tasks within this project. Task 1 is called Value of Research. Task 2 is a literature search. The value of research is required for all RTI projects, and basically what it is, it's a table or a matrix that describes what value we expect to get out of this research project, and it's required by RTI. The literature review scours research, peer-reviewed articles, and basically what we're trying to do there is not reinvent the wheel. If somebody's already done something that we're interested in, what we'll do is we'll move on and do something else. The SOP will be delivered in the first 120 days of the project. So first 3 months, we're talking about 4 months, well, let's see, 4 months. 4 months of the project, we'll get the SOP. And on the slide here, oops, I'm sorry, I got ahead of myself. Well, let's move on to task number 3. I pretty much said everything about the literature research that you could possibly say. Task number 3 is developing the standard operating procedures, and it's a big one. This is about half of the project. And on the slide here, I have 5 different general categories. When the project team was putting together the project scope, we actually had 44 of these. So I'm just showing 5 of them here. And to give you an idea of what's in these things, a level of detail, for instance, under the flight operations, we have qualifications for the operator, downed aircraft recovery plans, record maintenance, aircraft readiness review, imagery spillage, that's privacy issues. We have fuel handling, scheduled and unscheduled maintenance documentation, which is an FAA requirement, local rules and regulations, and frequency management. And that's just a small part. So this SOP is going to be comprehensive. It will be very thick. And we think that there's a good chance that it may be used by other Texas state agencies. And so we're taking this task very seriously. We're going to pay a lot of attention to it. Task number 4 is called a total system analysis, error analysis. This is the first of the nerd tasks. And I could spend an hour talking about this, and I'm afraid that you would say, damn, that's boring. And so basically what we're looking at here is how good the data is that's coming back from these UAS systems, these sensors. Every measurement has a little bit of error in it. Now, an error is not a mistake. An error is an uncertainty in the measurement. And every piece of a system contributes a little bit to that error budget. And so you get an overall error budget, and that limits the amount of accuracy that you can get out of any system. And so this is a very complex task. It'll take a lot of laboratory and a lot of in situ, which is out in the field investigation. And so this one's a serious one for me. This is the one that I think a lot of peer review articles tend to miss. Task 5 and 6 are the data collection tasks. For the pavement forensics, we're going to be looking at stuff like rutting, washboarding, how water runs off the pavement, where it pools. These are all quantitative tasks, so we're going to do data validation using total stations and digital levels. And for these tasks, what we're really looking at is an extremely high level of accuracy for our elevations. So you might think of these as micro DTMs or micro contour maps. Very, 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 very small changes in elevation. And again, the analysis part of this and the data validation are very, very strict. Task number 6 is a railway operations task. Within railways, there are 4 subtasks. We're doing corridor inspection, which is kind of like roadway inspection, bridge inspection. There's also a mapping task, which is sort of general mapping. And then there's also a volumetrics and quantities task within the rail application. The corridor and bridge inspection tasks are both qualitative, so they involve inspectors and subject matter experts. These tasks will capture live video, recorded video, and still frame. We aren't proposing to do any beyond line of sight work. Right now, that's not allowed by the FAA. If you have a drone up in the air and you're collecting data, the pilot in charge has to keep visual contact with that drone. If it goes outside of his visual contact, you're in violation of the FAA rules, which is very serious. Beyond line of sight it's research that's being done now to determine if you can operate a drone beyond the operator's line of sight and what you have to do to be able to do that successfully. And I actually have a couple of pictures here. This is actually the Burlington Northern Railroad. They're one of the FAA Pathfinder organizations, so they do primary research for the FAA. This is their command and control center out at a place called Playas, New Mexico. And when you get home, look at Google Maps. I was at Playas, New Mexico, and there's not a whole hell of a lot of stuff out there, except for this command center. But what they're doing there is they're using ground controlling radar, a bunch of different types of sensors, and they're trying to figure out if they can do an airborne sense and avoid, a ground sensor sense and avoid, airspace incursion detection. So this is a very, very sophisticated operation. It's way beyond the type of thing that we want to do. For our project, there is an outside chance that if the safety conditions are right and the FAA gives us a thumbs up, we may be able to do a little bit of experimentation, which would have to be with like maybe daisy chains of observers or maybe chase vehicles, but we're not counting on that right now, and we'll just have to see how that plays out. The bridge inspection task does have one other kind of interesting part to it. We're going to be using first-person viewing. So the bridge inspector will actually have a headset on that the camera system on the UAS tracks to. So as the inspector looks up, the camera on the UAS will look up. If he looks left, right, it'll track his head motion. In addition to the first-person viewing, there will also be an external monitor, and he'll be able to make a judgment call on if one works better than the other. And by the way, the inspector is not the pilot. There'll be a pilot who's actually running the UAV. The inspector is only looking at what the UAS is viewing. The third railroad task is a mapping task. It's mainly for railroad crossings, and it's used for safety. You know, a lot of times, if you have a red light, cars will back up over a railroad track, and that's a hazardous situation. So this task is just to look at various railroad crossings along the South Orient Railroad and get an idea of if this technology can be used for safety mapping. But the mapping task is very similar to a lot of mapping tasks that we do at TxDOT. So it'll be interesting to see how that one comes out. And then the final UAS task for rail is kind of interesting to me. It's the volumetrics. So you have stockpiles that you need to know the volume of, or maybe a construction site where they brought in material or taken material out and you want to know what the volume of that material is. That's what we're going to do with this last task for the railroad. But we're going to do it a little bit differently. Rather than start with a stockpile, what we're going to do is start with a rock cut, where the rail goes through a narrow corridor of rock. And it actually is pretty easy to figure out the volume in a rock cut. All you really have to do is just use an interpolated top surface, which is not very difficult. But the reason we want to use a rock cut is because it allows us to do something else. We want to know if there's a rock slide or if the rock wall has shifted. When the train comes through, is it going to hit it? So there's an envelope around that rail, that train, that vehicle, that we want to be able to superimpose on a rock cut to see if there's going to be any sort of interference with that train as it comes through. And that can be applied to a lot of rail corridors, you know, if you have a branch or a telephone pole or anything that the train potentially could impact. And so data validation for this one is done with a static LiDAR. The final task in our project, here I have it written down as policy recommendations. The actual name for this task is TxDOT Business Guidance and Policy Recommendations on the use of UAS. And so what this project does is it gathers all of the information from the technical task, from the SOP, and it tells us where we need to go with this technology. So in the project answers the how and the why. This very last part, the policy recommendations, it will answer the where and the when for us. And so I'm getting close to being out of time, but I just wanted to cover a couple other things that you need to know about this project. We know that commercial vendors are out there and they're ready to provide these services to us. And so this project requires that our university researchers identify at least 4 commercial vendors to participate in this project. For each task that comes up, the project team, the TxDOT project team, will take a look at the task and take a look at the commercial vendors in the university, and a decision will be made for who gets to fly, or who maybe get to is not the right word, because some of these are way the hell out in West Texas, but who has to fly the project. The project team is also required to have a registered professional land surveyor, a Texas registered land surveyor. That's for the data validation. The results of the project, including the development of the SOP and our workflows and procedures, that'll all be shared with the FAA. And we do that so the FAA, as they start developing their rules, they'll have some feedback and they can understand how people are using UAS. And then finally, the overall project schedule is about 18 months. And the reason it's so long is because of the field operations. It's complicated, logistically complicated. The analysis of the data is very complicated. And so 18 months is the overall project schedule.